Hello friends, today we will be discussing digital libraries and institutional repository software. Now, digital libraries and institutional repositories are emerging as a crucial component of global information infrastructure, adopting the latest innovations in ICT. The concept has brought a phenomenal change in the collection, management, and dissemination of information. Digital library is a library in which collections are stored in digital formats and accessed by computers. The collections may be stored locally or accessed remotely via computer networks. The Digital Library Development Initiative is probably the most promising development for libraries since the beginning of library automation. Digital libraries provide comparable or better services to traditional libraries at relatively low cost over existing networks and tools like those used for the World Wide Web. Traditional libraries are limited by storage space. Digital libraries have the potential to store much more information simply because digital information requires very little physical space to contain it. The era of digital libraries perhaps began with the emergence of e-journals, e-books, databases, etc., and they are now becoming popular, especially because of the fast emerging networks. The need for institutional repositories, or IR, arises out of a growing crisis in scholarly communication. Over the last 25 years, subscription prices to scholarly publications have increased at a rate so significant that many libraries have been forced to reduce their subscriptions. At the same time, the funding for libraries have stayed stagnant. Institutional repositories offer a strategic response both to the opportunities of the digitally networked environment and the systemic problems in scholarly communication. Institutional repositories are partly linked to the notion of a digital library, that is, collecting, housing, classifying, cataloging, preserving, and providing access to digital contents, analogues with libraries' conventional function of collecting, classifying, preserving, and providing access to analog content. Repositories may be limited to one field, one department, one institution, or a consortium of several institutions. Development of institutional repositories have largely taken place in universities. The open access and open archives movement, the need for change in scholarly communication to remove barriers to access, and the increasing awareness that universities and research institutions are losing valuable digital and print material have begun driving the establishment of institutional repositories. Digital library and institutional repository software. The rise of digital repository is significantly increasing in large part due to the fact that several digital repository software products are available as open source software. Several headlining OSS communities have formed to create successful digital repository software that is available for free. There are also, of course, proprietary companies creating digital repository software products. The digital library and institutional repository software should have the following features. Object model. The internal structure of the digital object in the digital repository system, existence of unique identifiers for the digital object, and every part of it is also important to ensure preservation and easy access. Collection and relation support. Collection description metadata, definition of subcollections and templates that describe the format of the digital objects or the presentation of the collection. Definition of relations between objects of the same or different types. Metadata and digital content storage. The storage capabilities are stated along with the preservation issues. It is important for digital repository systems to ensure standard as long as user-defined metadata sets and multiple formats of digital content. Search and browse. The mechanisms used for indexing and searching of the metadata. It is important for the digital repository system to support indexing not only for a restricted metadata set but also for selected metadata fields. Object management. Methods and user interface provided from digital repository system to manipulate metadata and digital content. User interfaces. Provided user interfaces for end-user access on the digital repository, its collections, and the digital objects. Access control. support for users and groups, authentication and authorization methods, level of restriction for access and update. Multiple language support. Multiple languages should be supported in the user interface, in the metadata field and in the digital content. The character encoding is of greater importance in order for the digital repository systems to be fully multilingual. Interoperability features. Standards that the digital repository systems support in order to ensure interoperability with other systems. Exports of the digital objects in open standard format is also important. Level of customization. Customization of the digital repository system in collection level, the format of the digital objects and the services provided. The quality and methods provided by the application programming interfaces or the APIs of digital repository systems. Greenstone. Greenstone is a suite of software for building and distributing digital library collections. It is produced by New Zealand Digital Library Project at the University of Waikato in the early 2000s. Greenstone is now developed and distributed in cooperation with UNESCO and the Human Info non-governmental organization. It is an open-source multilingual software issued under the terms of the GNU General Public License. A typical digital library built with Greenstone will contain many collections individually organized. There are several ways to find information in most Greenstone collections. Word search is provided as Greenstone constructs full text indexes from the document text that enable searching on any word in the full text of the documents. Indexes can be searched for particular words, combination of words or phrases, and results are ordered according to how relevant they are to the query. In most collections, descriptive data such as author title, date, keywords, and so on is associated with each document. Collections can contain text, pictures, audio, and video. Non-textual material is either linked into the textual document or accompanied by textual descriptions such as figure captions to allow full text searching and browsing. Unicode is used throughout Greenstone. This allows any language to be processed and displayed in a consistent manner. Multilingual collections embody automatic language recognition and the interface is available in all the major languages. Collections are accessed over the internet or published in precisely the same form on a self-installing Windows CD-ROM. Listed below are some of the special features possessed by the Greenstone. A. Accessible via web browser. Collections are accessed through a standard web browser and combine easy-to-use browsing with powerful search facilities. B. Full text and field search. The user can search the full text of the documents or choose between indexes built from different parts of the document. For example, some collections have an index of full documents, an index of sections, an index of titles, and an index of authors, each of which can be searched for particular words or phrases. Results can be ranked by relevance or sorted by a metadata element. C. Flexible browsing facilities. The user can browse lists of authors, lists of titles, lists of dates, classifications, structures, and so on. Different collections may offer different browsing facilities, and even within a collection, a broad variety of browsing interfaces are available. Browsing and searching interfaces are constructed during the building process, according to collection configuration information. D. Create access structures automatically. The Greenstone software creates information collections that are very easy to maintain. All searching and browsing structures are built directly from the documents themselves. No links are inserted by hand, but existing links in originals are maintained. This means that if new documents in the same format become available, they can be merged into the collection automatically. E. Make use of available metadata. Metadata may be associated with each document or with individual selections within documents. Metadata is used as the raw material for browsing indexes. It must be either provided explicitly or derivable automatically from the source documents. The Dublin Core metadata scheme is used for most electronic documents. However, provision is made for other schemes. F. Plugins extends systems capabilities. In order to accommodate different kinds of source documents, the software is organized in such a way that plugins can be written for new document types. G. Customization. The Greenstone allows customization of presentation of collection that are based on Extensible Style Sheet Language Transformation or XSLT and other agents that govern the definite functions of digital libraries. H. Designed for multi-gigabyte collections. Collections can contain millions of documents, making the Greenstone system suitable for collections up to several gigabytes. I. Multilingual support. Unicode is used throughout the software, allowing any language to be processed in a consistent manner. 4. Eprints. Eprints is a software for institutional repositories designed and developed by the Electronics and Computer Science Department at the University of Southampton and is freely available as open source software under the GNU General Public License (GPL). It was designed initially to create a preprint institutional repository for scholarly research, but is now used for other materials including reprints, technical reports, conference publications or other means of electronic communication. It is recognized as the easiest and fastest way to set up repositories of research literature, scientific data, student thesis and project reports, multimedia teaching materials, scholarly collections, digitized records, exhibitions and performances. Eprints is written in Perl, require installation of Apache web server and a number of Perl modules and uses the MySQL database as a backend. In Eprints, there is no such strict structural division into sections and collections that are still playing an important role, for example, to narrow the search to the repository. The idea is that all records are equivalent and do not form a hierarchy. Nevertheless, the hierarchy is needed to navigate through the repository since the user cannot exactly know the purpose of their search, having only a rough idea about it. The way to generate the navigation of any desired type using the related elements of the metadata field, that is, in Eprints, the problem is solved using the so-called representations. A way to generate the navigation of any desired type using the related elements of the metadata fields, that is representation, can be carried out on parts of the organization or by the author or a more complex version, the year of the publication and then by type, etc. Listed below are some of the special features of Eprints. A. Accessibility via web browser. Eprints provides web-based interface that make it easy to use and administer. B. Full text and field search. Searching in Eprints allows scanning each of the metadata field types in the database by using simple or advanced search. C. Administrative function provided. Eprints archive can use any metadata scheme as being provided by the administrator. The administrator decides what metadata fields are held about each ePrint item. D. Open source software. Eprints use traditional technologies and run on pure open source system. It uses MySQL database and Apache web server. Eprints is programmed by using the script language Perl that is low level but powerful. E. Multilingual support. Unicode is used throughout the software, allowing any language to be processed in a consistent manner. F. File formats supported. Functions with many file types including PDF, HTML, JPEG, TIFF, MP3 and AVI, etc. Metadata schema can be tailored to meet these requirements. G. Statistics. Statistics are provided for administrative usage. Statistical reports, summaries can be used for performing analysis on repositories. H. Customization. The Eprints data model consists of user-defined metadata. In order to export data in other formats, plugins can be written. I. Item preview in Eprints. Thumbnail preview of documents and image is generated automatically upon file upload. Dspace. Dspace is a popular open-source application for institutional repositories designed to capture, store, index, preserve, and redistribute the intellectual output of an institution in digital formats. It was jointly developed by HP Laboratories and Massachusetts Institute of Technology Libraries. Dspace is an OAI-compliant application that can be downloaded from Dspace website under the BSD open source license. Like Eprint repositories, Dspace repositories can be used for archiving both reprints and other digital data. However, Dspace places an emphasis on preservation of all types of digital information, including journal papers, electronic theses, reports, conference posters, videos, image, etc. The Dspace architecture consists of 3 layers: application layer, business layer, and storage layer. The application layer covers the interface to the system, the web, and the user. The business layer contains the Dspace specific functionality, workflow, content management, administration, and search and browse modules. The storage layer is implemented using the Relational Database Management System, Postgres SQL. Each module has a well-documented API and all original code is in the Java programming language. Other pieces of the technology include a web server and Java Servlet Engine, Jenna and RDF Toolkit from HP Labs, and OAI CAT from OCLC. In Dspace data model, each item has one qualified Dublin Core metadata record. The Dublin Core may be entered as end users as they submit content, or it might be derived from other metadata as part of an ingest process. The major features of Dspace are: A. Authentication. Dspace allows contributors to limit access to items in Dspace at both the collection and the individual item level. Authentication is provided through user passwords, X509 certificates, or LDAP. Access control can be administered by only authorized users. B. OAI PMH support. Dspace exposes Dublin Core metadata for items that are publicly accessible. Additionally, the collection structure is also exposed via the OAI protocol's sets mechanism. OCLC's open source OAI CAT framework is used to provide this functionality. C. Object management. The process of item ingestion in Dspace is via a web interface or batch item importer. In workflow process for item submission will initiate depending on the configuration of collection. The workflow process may contain one or more steps as per the user need. The collection and communities in Dspace are created via web interface. D. Import and export. Import and export for communities, collections, and items is supported by Dspace. It also includes batch tools to import and export items in a simple directory structure where the Dublin Core metadata is stored in an XML file. This may be used as the basis for moving content between Dspace and other systems. E. Statistics. Statistics are provided for administrative usage. Statistical reports and summaries can be used for performing analysis on repositories, providing information like number of items uploaded, searched, number of e-people registered with the system, etc. F. Handle system. To help in creation of persistent identifier for every item, Dspace makes use of Handle System's global resolution feature. Dspace requires a storage and location-independent mechanism for creating and maintaining identifiers. Dspace uses the CNRI handle system for creating these identifiers. G. Customization and types of document supported. Dspace allows customization to accommodate the multidisciplinary and organizational needs of a large institution. Dspace collections include audio, video, or text depending on the organizational needs. The system can function with many file types including PDF, HTML, JPEG, TIFF, MP3, and AVI, etc. H. Standard compliance. The default configuration permits Dspace to store metadata of an item in the Dublin Core metadata schema. This ensures that data can be exchanged with other standards compliant systems such as Mark 21. 6. Fedora. Fedora is a digital asset management (DAM) architecture on which many types of institutional repositories, digital archives and digital library systems might be built. It is not a complete management, indexing, discovery and delivery application. It has a modular architecture built on the principle that interoperability and extensibility is best achieved by the integration of data interfaces and mechanisms as clearly defined modules. The architecture is based on object models that by definition are templates for units of content called data objects, which can include digital resources, metadata about the resources, and linkages to software tools and services that have been configured to deliver the content in desired ways. Fedora was originally developed by researchers at Cornell University and the University of Virginia Library as architecture for storing, managing and accessing digital content in the form of digital objects inspired by the Kahn and Wilensky framework. It began as a DARPA and NSF-funded research project at Cornell University's Digital Library Research Group in 1997, where the first reference implementation and a Cobra-based technical implementation were built. Fedora defines a set of abstractions for expressing digital objects, asserting relationships among digital objects and linking behaviors, that is, services, to digital objects. In 2003, Red Hat Incorporated applied for trademark status for the name Fedora to be associated with their Linux operating system project. Cornell and UVA formally disputed the request, and as a final settlement, all parties settled on a coexistence agreement that settled that the Cornell UVA project could use the name when clearly associated with open source software for digital objects repository systems, and that Red Hat could use the name when it was clearly associated with open source operating systems. Fedora provides a general-purpose management layer for digital objects. Object management is based on content models that represent data objects or collections of data objects. The objects contain linkages between data streams, system metadata, and behaviors that are themselves code objects that provide bindings or links to disseminators. Content models can be thought of as containers that give a useful shape to information poured into them. If the information fits the container, it can immediately be used in predefined ways. The Fedora system supports various standards: OAI, PHM, exports to METS formats, and its own internal format, FOXML. The descriptive metadata are stored in the Dublin Core format. This enables interchanges between Fedora and other XML-based applications and facilitates archiving tasks. The Fedora digital object model allows tight management of metadata and digital content regardless of the format. The system is scalable and flexible, allowing to associate objects with external or distributed repositories. Objects and behaviors are separated, making it possible to change the required behavior by altering the mechanisms without changing the objects themselves. The Fedora project is currently supported by Dspace organization. Fedora repository project implements the Fedora abstractions in a robust open source software system. Fedora provides a core repository service. In addition, Fedora provides an array of supporting services and applications, including search, messaging, administrative clients, and more. It provides RDF support, and the repository software is integrated with semantic triple store technology, including the Mulgara RDF database. Fedora helps ensure that digital content is durable by providing features that support digital preservation. The rise of digital libraries and institutional repositories is significantly increasing in large part due to the fact that several software products are available as open source software. There are also, of course, proprietary companies creating digital repository software products. The advantages of having many choices becomes a great headache when selecting a software package for a specific organization. It is difficult to propose one specific software as the most suited for all cases. Each system has its advantages and drawbacks. Usually, the need for each organization vary depending on the number of collections, the object's type, the nature of the material, the frequency of update, the distribution of content, and the time limits for the development of digital library or institutional repository. Before we move to the next session, please try to answer the following questions. Differentiate digital library and institutional repository. What are the major features that expect from a digital repository system? What are the major features of Greenstone digital library software? What are the functions of Dspace, Eprints and Fedora? Books for your reference. OCLC Systems and Services, International Digital Library Perspectives. H.F. Cervone, 2006. The Case for Institutional Repositories, a Spark Position Paper, Washington, D.C., Scholarly Publishing and Academic Resources Coalition. R. Crow, 2002. Open Access, Open Source and Digital Libraries, a Current Trend in University Libraries Around the World, Program, Electronic Library and Information Systems. M. Krishnamurthy, 2008. Institutional Repositories in Indian Universities and Research Institutes, a Study, Electronic Library and Information Systems. T. D. Kemparaju and M. Krishnamurthy, 2011. With that, we come to the end of this session. We'll be back again with another one. Until later, goodbye.